Guys, I hope that you're all doing well. Today's lesson is about trigonometry, and this is the second video where we'll be expected to construct a triangle. So we have a question here: if tan theta is equal to negative 4/3, we have that information, and we also have our case diagram on the left hand side that I sketched, and under we have the steps that we need in order to solve this question. But before we continue, remember I told you that you have to learn how to decipher your intervals. You need to know what they mean. And if you don't, all your answers will be wrong. So you need to make sure that you master intervals. So before we start, I want to tell you different ways they'll introduce intervals. The first one might look like, let's say, 0 degrees is smaller than theta, and you might have 90 degrees. What this means is that theta is between 0 degrees and 90 degrees. To see this on a case diagram, you'll just say 0 degrees plus and 90 degrees minus. It should be greater than 0, but not bigger than 90 degrees, excuse me. So you can just say 90 degrees plus, 0 degrees plus, but 90 degrees minus. So when you go to your case diagram, where's 0 plus? That's your 0. 0 plus means it's in the first quadrant, okay? So there is 0 plus 90 minus, that is your reduction, there's your 90 minus. They might also say theta is an element of 90 degrees and 180 degrees. What this means is that you can just write this as 90 degrees plus and 180 degrees minus. So when you go to your case diagram, you look for 90 plus, there's 90 plus, your reduction. Can you see? 180 degrees minus, where's 180 degrees minus? There's your 180 degrees minus. Excuse me, 90 plus is a cofunction. 180 degrees minus is a reduction. There's your 180 degrees minus on your case diagram. So can you see that this one's also easy? The third way, let's try an example. Let's do 180 smaller than theta smaller than 270 degrees. What this means is that we have 180 degrees plus and 270 degrees minus. On your case diagram, where's 180 plus? There's 180 plus in the third quadrant. You have 270 minus, so this is 270, right? Meaning minus would be here in the third quadrant. It wouldn't be there because it would be 170 plus. So it's there in the third quadrant. And that's what it means. Let's try sine theta is smaller than 0. They might give you this information. What they mean is that sine is negative. We know this because they said sine theta is smaller than 0. Okay, so you have to look for quadrants where sine is negative. Where is sine negative? Sine is negative here and there. That's what it means. Let's try the last one. They might say cos theta is greater than 0. What this means is that greater than 0 is positive, which means cos is positive. You look for quadrants where cos is positive. Cos is positive here, and it's also positive there in the first and the fourth quadrant. So I really hope that you guys understand this. If you don't, please make sure that you practice this and that you check out a few examples, try different question papers, and you'll see that the constructing triangles question is actually very approachable. Now let's solve this. We have, if tan theta is equal to negative 1/3 and sine theta is greater than 0, determine the values of the following without a calculator. Cos theta, sine theta, 3 cos theta plus 4 tan theta. What's the first step? We have to solve the equation if necessary. We have tan theta is equal to negative 4/3. We don't need to solve this. This is already simplified. So we move to step 2, which is choose the quadrants. Okay, so they're telling us here that tan theta is equal to negative 4/3, meaning tan is negative. In which quadrants is tan negative? It's negative in the second. Let me highlight this in blue. It's negative in the second and the fourth quadrant. Right? Our interval says sine theta is greater than 0. So what this means is that sine is positive. As I explained, if something is greater than 0, then it's positive because it's bigger than 0. So in which quadrants is sine positive? Sine is positive in the first and the second quadrant. So can you see now that in the second quadrant we have 2 ticks? That means we're supposed to draw a triangle in the second quadrant. We chose our quadrant. Now let's draw our triangle. We have the y and x-axis. We have to draw a triangle in the second quadrant. So we start from here to there and then down to the x-axis. We have a 90 degrees there. Theta is measured anti-clockwise from the positive x-axis, meaning from here to there. We should have theta, but we should also have theta there so that it's less confusing for us. We have tan theta is equal to negative 4 over 3. Tan is equal to opposite over adjacent. So this is O over H. What is the opposite side of this right angle triangle? The opposite side is the one across your angle. There's your opposite side. It's negative 4O. And then the adjacent side is 3. However, in the second quadrant, the x value is negative and the y value is positive. So this should be positive 4. And that should be negative 3. That's what I explained in the previous video, what I started with. Okay, we have the two sides. Now let's solve for the hypotenuse. To do so, we have to use our Pythagoras theorem. We'll say x squared plus y squared is equal to r squared. I hope you guys still remember this. I did this in the previous video. So let's substitute our x squared. We have negative 3 squared plus 4 squared is equal to r squared. Remember, r squared is our hypotenuse. We have 9 plus 16 is equal to r squared. Then r squared is equal to 25. Use a square root on both sides. Your r would be 5. And remember, the hypotenuse is always positive. So our r is 5. Let's write this here. 5. That is our r, that is our x, that is our o. Okay. Then, no, actually it should be h. We don't use r here. So hypotenuse. And this should be adjacent. Okay. So we've already updated our triangle. Now it's time to solve. A, we have cos theta. Cos is equal to adjacent over hypotenuse. What is the adjacent side? The adjacent side is negative 3. And the hypotenuse is 5. So A, cos theta is equal to negative 3 over 5. Now let's try B. We can rub this. B is sine theta. What is sine? Sine is opposite over hypotenuse. Let's use a triangle. What's the opposite side? 4. What's the hypotenuse? 5. So sine theta is equal to 4 over 5. Now let's do the last one. Let's do C, which is 3 cos theta plus 4 tan theta. To solve this, we can say 3 in a bracket. Let's find cos theta. What is cos theta? We found it in the previous video. It's in the previous example. It's negative 3 over 5 for A, right? Plus, let's say 4. Then substitute our tan theta. What is tan theta? We were given tan theta. It's negative 4 over 3. Now let's solve for this. They said without a calculator. So let's take this step by step. Put this in a calculator. They said without a calculator. But as I said in the previous video, use it to avoid making any mistakes. So this will be negative 9 over 5 minus, punch this in your calculator. Actually, this should be plus, but when you punch this in your calculator, your answer will be negative. So this is negative 16 over 3. Now let's try to find the common denominator. our common denominator is 5. You guys know how to deal with fractions, right? So I'll just make this quick. You'll end up with negative 27 over 15 minus 80 over 15. We have a common fraction, so let's combine. This will be 27 minus 80, which is negative 107 all over 15. And that is how you deal with questions that require construction in trigonometry. Thank you guys for watching. If you want more videos on this, please let me know. For now, I'll try to upload more grade 12 content.